Hello, Science Sunday lovers. It's Mike Winter and Scott Thompson. I'm taking my mask off now to communicate better, and here we are at DUC. Science Sunday, as always, is extremely grateful to the DuPage Unitarian Universalist Church for providing us with not only this physical space that allows us science lovers to meet and discuss the awe-inspiring mechanisms of the cosmos, but also provides us a psychological space where we can explore, question, and share our thoughts about life and its meaning. One thing that this COVID-19 outbreak is making extremely clear to all, I believe, is that this beautiful, intricate, expansive web of life that is so precious to us all, it hums and vibrates, thrills, and yes, sometimes tatters in complex ways that we mortals long to understand. That's one reason why we're here today. Time is short today. There's a lot to cover. I think I bit off quite a bit in my discussions of consciousness, and so we'll dive into it right away from there. But Scott and I have both prepared pretty well for this. I think that I hit so many kind of interesting topics and things to think about and so on. I don't believe my segues are very good, moving from one topic to another. But there's just so much to see and explore and to look at it about this that I didn't complicate my life more by trying to blend smoothly. So I apologize for that if it brings out a little bit of disjointedness to the talk today. But we've got a lot to cover and a lot of interesting things to try to understand.
It'd be a little jarring, like the time change we just lived through.
Right. I don't know who decided that we needed one more hour in 2020, but...
oh my gosh, good point.
We could have lived without one extra hour in 2020 this time. The science of consciousness. Interesting topic. And I wanted to start out just with some level of a discussion here first, and this is one area that I kind of added in the last few days. But have you ever compared a brain to a computer? I think it's kind of a common topic. We think of our brain as somewhat of a computer, and you hear some interesting things about the brain acting as a computer. I wanted to talk about that and read a little bit of something from an interesting book that helped me plan for today, and then go on from there. But there's a challenge ahead for us to understand about consciousness, and this may help us kind of get a base point. We have amazingly probabilistic parallel computers that run inside our heads, is the standard way of looking at it right now, with a lot of great capacity, but they're also bound by the means that they were constructed, by which they were constructed. And really the means by which our brains were constructed is evolution, which we've talked about many times in Science Sunday. So we have an object in our head that acts as our computer, acts as our lead in decision making and so on, that is a function, the product of 4 billion years of life on Earth. Assume for a moment that a single neuron is capable of just one rudimentary calculation. That's not true, but there are roughly 85 billion neurons in a human brain. An average PC processor, a regular computer that you have at home that maybe you're looking at this presentation by, has about 100 million components or so. That's about 850 times fewer components than is in your human brain right now. An impressive win for humans, but not staggeringly so. And indeed, there are some supercomputers today that have more components than a human brain has neurons. One is down at the University of Illinois in Champaign. But this is only the beginning of the story. There is another critical feature of human brains that in a race would leave any computer in the world stumbling along, choking pitiably on the dust of our own supercharged biological computational device. While each component on a central processing unit may be connected to only one or a handful of others, each neuron in the human brain is connected to, on average,
about 1 million others, I think.
My numbers are 7,000 that
Oh,
each are connected to. This means that there are some 3 or 600 trillion connections in the brain, which is about 3,000 times more than the number of stars in our galaxy. In one brain, right?
And that's just the neurons.
That's just the neurons, right?
Yeah, there's other cells called astrocytes that have recently been implicated in regulating neurons. It used to be thought that they were just scaffolding that neurons would cling to. But these astrocyte cells, which were neglected in studies of cognition, have been shown to have some inhibitory and excitory effects on neurons.
And we'll be talking about some of those things too, I think. 3,000 times more than the number of stars in our galaxy are connections in your brain. In every young adult human brain, these microcables, extended end to end, would run about 165,000 kilometers, enough to wrap around the Earth 4 times over. The complexity of the human brain is utterly staggering.
Inconceivable.
Right. To begin to understand the sheer vastness of the parallelism of human brain activity, imagine that the human population is around 85 billion people, okay? Just imagine the human population, about 85 billion people, about 12 times what it actually is right now. You, personally, have suddenly discovered an earth-shattering revelation, and you simply have to tell everyone. You email every single person in your contact list, all 100 people, and tell them to pass this wondrous insight on to 100 new friends. They do so. Then the next group follows the same instructions, and so on. Let's assume for the moment that there are only a few overlaps in most people's address books, so 100 new people get each message from 100 other people. And for the sheer, unadulterated genius of the wisdom imparted, that everyone obeys the instructions to forward the email within a few seconds. From the starting point of a single send, your send to 100 people, it actually only takes 6 steps for the whole multiplied world of 85 billion people to get the message, and just a handful of seconds. Indeed, in the human brain, it's thought that no neuron is more than 6 steps away from any other neuron in the family of 85 billion. 6 steps to contact and make a connection to any other neuron in your brain. Now, imagine everyone in the world having such a revelation and everyone emailing their 100 address book contacts about the news each time. And everyone doing this, let's say 10 times an hour, every 6 minutes.
It sounds like my inbox.
If you didn't turn on some fantastically effective spam filters, your inbox would receive around 1,000 emails an hour. Everyone in the entire population each receives 1,000 emails in that single hour, collectively amounting to 85 trillion messages. That's if you send one message every 6 minutes, or 10 in an hour. But a neuron, instead of firing 10 times in an hour, may fire 10 times in a second. 360 times faster than that, right? Or 3,600 times faster than that, excuse me. And send its output, instead of to 100 other neurons, it could send its output to 7,000 other neurons. So, a nauseatingly dizzying complexity occurs in your brain every single second. That's what's going on in your brain every second.
It is nauseating, just the thinking of it.
With hundreds of trillions of signals competing in a frenzied, seemingly anarchic competition for prominence. This massively parallel web of neural activity simply is the propagation of information. In many ways, this spread of data by minuscule parts is unintuitive. A personal computer stores a single piece of information in only one location, and that location cannot store any other data. In stark contrast, populations of neurons, those, for instance, in the fusiform face area, store as an ensemble many different faces, with each neuron only contributing a small fraction of each memory for a particular face, but humbly capable of playing its minute part in supporting hundreds or even thousands of face memories. But for all these differences, the fact of the matter is that both brains and standard computers are essentially information processing machines and are secretly far closer cousins than it first appears. The same concepts apply, it's just the capacity of each is so remarkably different. So whatever algorithm a brain uses to process information could potentially be recreated, in principle, on a personal computer. Indeed, in neuroscience, there are already prominent computer models closely approximating the biological characteristics of a large population of neurons. In one recent case, 1 million neurons, not the amount that we actually have in our brains, with 500 million connections. And these are showing interesting emergent trends between groups of pseudoneurons, such as clusters of organizations and waves of activity, things that our brain seems to show the capacity to do as well. So I thought that was an interesting comparison of a brain to a personal computer, to try to get some level of idea, of concept of what's going on in there. We'll delve into aspects of that further, and what are we doing with all this information, and what can the brain actually manipulate out of all that information? And there's
Posting cat pictures, that's what I'm doing.
Posting cat pictures? That's good. I think that's fairly harmless, and I'm glad to hear that, actually. So, with that as kind of the overview of what is going on in the brain, I'd like to investigate some more in what we've thought about, how things have developed, what concepts were in the past, and what we're learning more and more about the brain. It's going to be a very whirlwind trip through this cosmos of the brain today, and there's so much more to understand and learn that we can only touch and delve at certain surfaces.
Maybe we'll do a third one.
Yeah, could be. I mean, it just is so amazingly overwhelming. A little philosophy to start out with. I wanted to do a little bit of background. These are Enlightenment thoughts from the mid-Enlightenment time or even before. They crystallized earlier ideas that were really from the beginning of humanity. Remember, scientific studies or tests of these theories were not really available or were very limited at that time. They couldn't do the things that they can do nowadays. And really what's happened in the last 50, 60 years have been the capacity of doing electroencephalograms, all sorts of different functional MRI testing to see what parts of the brain activate at what time and why, and exactly the time frame that occurs with it. But these are the basic ideas that were thought and were held by humans because they fit into an overview of what possibly was how the brain worked and what it did. One thing is there's been discussions for a long, long time. Is there a difference between your mind and your brain? This is the mind-body dualism experience or discussion. And what is really going on? People felt like there had to be more than just what your brain can contemplate because there's so many feelings and thoughts and emotions and activities and so on going on. How can the brain or any part of your body comprehend that? There was a lot of thoughts about this in ancient times with the Greeks, and they didn't know how to. It's a human thing to question how you know things and why you know things and where they're at.
Well, some cultures even thought the heart was the center of consciousness, not the brain.
Right,
Yeah.
right. And another thing they were very interested in is, can your mind or your consciousness continue after your body stops? That can be a kind of, it's been thought of as a very comforting thought to know that some part of you goes on, that you aren't controlled by your breathing and your life force that's there. When you stop, how do parts of you or do parts of you continue, right? And it becomes a very comforting thought and a very important thought to many religions. It's been a major underpinning of most standard religions, is that you are not just controlled by just the physical functions of breathing and eating and sleeping and talking and so on, but there's an essence of you. And it's an easy description, an easy answer for many thoughts of how how we fit into the world, and how important are we in the world, and so on.
We seem to occupy our bodies. We talk about our bodies as if we are separate and we own it. It's my hand. It's my nose. So this idea comes naturally to a lot of first-order thinking.
Right. And it became very important. It somewhat fed itself because it supported religious thought at the time, and religious thought controlled much of how people acted and responded to the world. So it fed upon itself, and it was something that many philosophers had to find a way to say that there was something beyond just your physical self. Mm-hmm. So, and there's not really any way to prove some of that. There got to be a lot of discussions. One famous idea was with this mind-brain controversy was cogit ergo sum, okay, which is posited very famously by a philosopher we'll look at in the mid-1600s, and it was basically, I think, therefore I am. Okay. A lot of discussion went on with how that fit into the world. Basically, the conceptual thought of it was that you can question, sort of like the Matrix with Neo and the red pill and the blue pill and so on, if you're familiar with the Matrix stories, that you can question, you can be put in a situation where you can actually question whether your body is what is yours or not. Your body cannot exist or can exist. You can question, you can doubt the existence of your body. You may just be the... What's that?
You could be living in a simulation,
right,
hypothetically.
Right. You can be just a creation in your mind that says that this is the body that I live in, and this is the world I inhabit, and so on. But there is no real proof of any of that at all. You have a hard time proving that your body is there and it's not just a simulation or a creation in your mind that your mind makes up. And so then the concept gets to be that you can doubt the existence of your body or you can accept the existence of your body, and neither proves anything about it. But if you start talking about your mind, according to the philosophers of the mid-1600s, you can doubt your mind, but the fact that you doubt that your mind is thinking and processing things is actually a proof that your mind exists. The capacity of you to doubt or to think about this proves that you have a mind that's doing that. In the same fact that you can either accept and say that I think that I have a mind, that proves that you have a mind because your mind is thinking about it, or I doubt that I have a mind, that proves that you have a mind again because you have the capacity to think about it and to sum it all up and discuss it.
I think not.
Yeah, I think so. So this was a philosophy, and actually it held sway for a long time, for a few centuries. There were people that disputed it, that said some things about it. We can start talking about things. But this, without the capacity to really look into the mind and see, is there something that your mind can do that doesn't really show with any activity in your brain or show with any activity in your body, just sitting there thinking or staring at a wall or any of these aspects of what you can do, sleeping. All these things show the fact that your mind is active in there, but your body may or may not. Since we can doubt the existence of our bodies, in other words, but never our mind, the mind must be distinct from and independent from the body. This isn't, again, showing like I had it on my, something's a little bit different in the playout, but that's the theory. Since we can doubt the existence of our bodies, but never doubt the existence of our mind, these philosophers believed the mind must be distinct from and independent from the body. So, this brings to mind, and we'll go a little bit further into some of this, the mind-body controversy or dualism is what's there, that mind and brain can have different aspects, can be each a different aspect from each other. Your body is not necessarily tied to your mind, and your mind is not necessarily tied to your body.
Like a soda is both the flavored water and the carbon dioxide. They're both together and they make a whole soda, but they're very different things and they can be separated.
Right, and some of that, again, without experimental principle or thought, how can you deny this potential, this possibility? And we'll talk about how some pushback came about with some of this. Now, I don't know, when I've said some of these things, maybe some of you at home have come up with this philosopher, dragging him out of your mind to bring back this idea. Are you familiar with the philosopher that I'm talking about here?
Yeah, right.
Okay. This is a picture of him.
You put him before the horse.
I did. I put the Descartes before Deshorse.
Yeah.
René Descartes, 1644, was positing this kind of idea, and his basic thought was cogit ergo sum. Leibniz was born just about when Descartes died, and he was one of the early people to push back against him. But it really did maintain as a basic underlying premise for hundreds of years, and still even has great influence today. It still seems to have, it fits into philosophies, it fits into religion, it fits into a lot of things. Leibniz basically said, just because Descartes can contemplate this possibility doesn't prove anything. The fact that you can contemplate something doesn't mean that that's true.
I can think about dragons and unicorns.
Right.
Right.
Right. I guess the question gets to be then, are there times when consciousness radically alters, yet the brain remains the same? If the brain and your mind are completely different, if the physical expanse of your brain can show no change in it while your mind is active, that gets to be the experimental, developmental way of trying to test Descartes' theory.
And the other way around, right? If your cognitive identity remains constant, even though there's some significant change in your physical brain, then that's also potentially evidence.
Right, right. So this is how some of the pushback started with some things like this. Actually, before this, like I said, very little experimentation. Nobody was diving into the human brain with ice picks or anything like that to try to solve what was going on in there. So
It was the Middle Ages. I'm a little surprised.
So, actually, this fellow, this was still solid and strong until this guy, well, he was another person that had some interesting discussions about it I want to just touch on a bit. And then there were a lot of pushback prior to this that we'll go into in the next slide. But this is Gilbert Ryle. And in 1949, he started talking about this, and he was responding again to Descartes 300 years earlier, whose ideas still held a lot of weight. And he was talking about that there was some level of not understanding. Descartes didn't understand the true capabilities of the mind. The mind can do many more things than Descartes was willing to understand. Descartes would probably not even contemplate the possibility of unconscious activity in the brain. He thought that the brain was doing the things that we think of, cognition more than consciousness. So he came up with a term, the dogma of the ghost in the machine. Basically, if you think of your brain as a large machine, which we talked about to start off the discussion, Descartes is saying that this machine is just there doing things, and there's a ghost flying around doing these activities throughout all this going on. So your thoughts and the mind is this ghost flying around the machinery.
And the ghost could leave.
And the ghost could leave at times and come back and call in a friend possibly or anything else. But Ryle was saying that really, if the machine is doing the work, if the machine is actually the process by which we use cognition, in which we undergo consciousness, and by which our mind activates, then you don't need a ghost to make the machine work. The machine is the machine, and it's been developed and works to do the processes by which it continues. So that sounded pretty interesting to me. I thought that was a very good explanation of it. You don't dualism and this mind-brain controversy, I think most scientists now, with experimentation, some of which we'll talk about, and many more we don't have the time to talk about, has shown that there's activities going on in the mind that are functions of your brain and functions of you as a living thing, right?
There's another name for that. Are you going to mention that name for
Go ahead.
monism?
Monism instead of dualism.
Right.
Okay. Yeah, I didn't come across that.
It's like monolithic, one thing.
Right.
So monism is the idea that stands opposed to dualism, that says that what happens in the mind and what happens in the brain are aspects of the same underlying phenomena.
And you don't need the ghost flying around doing
Right.
the things that it does. The mind is not some added feature of the brain. The mind is the activities that the brain pursues.
That's a good way to put it.
Thank you. So are there times when consciousness radically alters, yet the brain remains the same? And most people exploring the concept of consciousness in the brain would say, no, there's always some activity that can be perceived that's actually occurring with the capacities that people have now to do functional MRIs and EEGs and all the different means by which they can explore what goes on in the brain. There's always something happening. There's one concept I think we talked about a month ago in terms of, it's a little bit of a side, but it kind of jumps to mind right now, where people who are unconscious to the extent of maybe being in a coma or appearing like there's nothing much going on, and they try to discuss and decide how that person, which seems to have no capacity to communicate, how we can engage with people like that. And so there was a discussion, and actually one of the books I wrote, the author was in some of the preliminary testing of it, and he was put into a functional MRI. He was a healthy, scientific observer, but they were testing him, and they said whenever he wanted to answer yes to a question, he was supposed to think of organizing his house and putting things in the house in a proper place. And that caused certain activities, certain areas of his brain to engage and fire, and the neurons in that area to fire. And so they could test that and see that. Whenever he wanted to say no, he was supposed to think of a physical activity, which he picked as playing tennis, and he'd think about his forehand swing and these physical activities, and a whole other area of his brain would fire and be engaged. And they went on with a communication, a conversation. He was completely quiet inside this magnetic resonating sensor, all hooked up, and his buddy, who was going to be the lead experimenter on this, kept asking him questions. He said, do you have any siblings? And he thought, yes, yes, yes. So he thought of cleaning his house, and he thought of all the things he did that cleaned his house. And the guy said, oh, so you have siblings. Do you have one, or do you have one? And he said, no, no, no. And so then he thought of playing tennis. And they had a communication that went on for a few hours in which the fellow up in the testing booth was able to communicate and hear these things, even though this individual never said a word and answered questions that the questioner had no idea what the answers were for. So there's actually ways of the mind being able to be used to communicate in ways with people who have no capacity.
They did this similar thing with people who were in comas.
Right. Then they went out and did that, and it has different levels, as you'd imagine, of success. Some people's comas or some people's lack of consciousness is so different, is so inhibited that they profound that they can't communicate this way. But there were a significant number of people who could actually communicate by thinking of these activities, physical activities, or their home order, or things like that too. But the first studies of this that tended to prove that the mind, the monism that you talked about, Scott, were not as complex as that. We'll go on to another one. The famous PHINEAS gauge in 1848. This is like a scientific study. There's data here. There's amazing things. And the big data was that Phineas Gage was a construction foreman on a railroad building project, and they were clearing large rocks out of the path of that the train tracks are going to take, and they were putting dynamite into crevices in there, and they were kind of tamping this dynamite in. And Phineas Gage was holding on to that stick that picture shows. He was holding in his hand. Someone had the presence of mind to capture it, because that's data as well. It was about a inch diameter and about 3 foot long piece of pipe. He pushed into this hole, pushing down the TNT, and it fired, and it shot this spike, and it traveled a very extraordinary path that went through his jaw and out the top of his head, right behind his left eye. He was actually pretty cogent after this all happened. He was able to get up after a minute, and he walked over to a cart. They put him on a cart that was on the train track and brought him back to town, and he was able to talk through all of this and everything. He became an interesting topic of study, right? He was known as a well-balanced, smart, sociable, respected, responsible young man at the time this occurred. And he had no problems with his language, with his capacity to move around, do all these different things. But basically, there were some significant changes, and people noted that he became much more immature, subject to very profane language. He was disrespectful and capricious.
Sounds like some politicians I know.
More like some Unitarian Universalists I know.
Oh, my goodness.
But unable to follow through on plans, all these different things. Yeah, it does sound like politicians. And his friends, the common topic was he was no longer Gage. He wasn't Phineas Gage anymore. Now, how can it be that a physical injury like that can change your mind? It tends to lead to data that shows that your mind and your brain are linked in and tied and work together, right? So this is some of the first data. There were other data from other people with injuries and things like that. So as time went by and as science got more data and more data, it's become more and more of an understanding that the mind and body are together, work together in unison, in concord. Monism is ruling the day in scientific thought now. But it's still a tough fight because it has some religious implications, some philosophical implications. It flies in the face of what a lot of religions and people want to say, that your mind is your own cohort. But okay. Scott, I know, did a lot of reading and studying about some of this topic too, and this was something, again, this is my poor segue right here, but I wanted to talk about cognition, just to make sure maybe that our terms are right, and we're talking about things as we go on further that define and make sure that we're all on the same page with things. So when you talk about cognition as compared to consciousness, I don't know if you can think of something in your aspects before we start revealing, but what's the difference between cognition and consciousness?
By the way, we have 13 people
Great.
live watching us today.
All right. 2 days before the election. Cognition. Cognition is a conscious mental activity. It's the activities of thinking, understanding, learning, and remembering, okay? So cognition is the processes that your brain is going through as it's manipulating data and coming up with solutions to tasks or problems you may have, okay? And maybe that helps you start thinking how consciousness is somewhat different than cognition. We aren't just talking about you processing information here in consciousness, but consciousness is the quality or state of being aware, especially of something within oneself. So consciousness is the capacity to understand that something is occurring and you can be aware of what's happening and how it affects you. It may be actually a process created by the biological computer we talked about in your brain, whose driving purpose is to process information. So we're mainly concerned with consciousness today, but I wanted to see if you had some thoughts about this in terms of cognition and consciousness.
Yeah, I have, I've done quite a bit of reading about this. It's hard for me to imagine that you can be a conscious being without being curious regarding this particular question and topic. So, I'm safe, by the way. I'm not afflicted with any virus, so you can hear me a little better. Take my mask off. And some of the reading I did inspired me to convey to you all this interesting vignette. Think of a garden slug, all right? A garden slug, if you see one crawling along in your yard and you take your finger, or maybe it's too slimy, so you take a little stick and you try to touch the leading end of a garden slug, or maybe a snail that can curl up into its shell. Well, as soon as you touch the front end of that slug or snail, what happens?
It retracts.
It retracts. Oh my goodness, you're out to get me. You want to eat me or whatever. I don't think it's accurate to say that something goes through its mind, like fear. It has a very simple neural network. But here's an interesting thing that I didn't think about until I read about it. When a slug or a snail, I actually read about an earthworm, but when it's crawling along and you watch it crawl along, what happens when it comes to a blade of grass or a wall? As soon as it touches that blade of grass or wall, does it go, oh, I'm going to be eaten? No. But it's the same physical input as bringing the wall or a blade of grass or a little stick to the animal. So the same physical process of coming into contact with a surface in a world with moving parts, that same sensory input, potentially an identical sensory input, leads to very different behaviors on the part of something as simple as a snail or a worm. And cognitive scientists have thought about this problem. And they've determined that even in primitive organisms, that's probably a bad word to choose, primitive, even in less complex organisms with relatively simple neural networks, there must be a kind of feedback loop that says, I just touched that wall or that grass or that stick that I'm climbing. I just touched it because I am moving. Mm-hmm. And so I need not be afraid. I need not react defensively. Now, this is how we would put that into English words. But this feedback must be a primitive aspect of the way that creatures who volitionally move through their environment or interact with their environment or manipulate their environment, this feedback loop must be a necessary component of navigating the world. You must be able to differentiate your impacts on the world from the world's impacts on you, even though the stimuli can be similar.
And even, I could imagine that it has the capacity so that if it's moving, but you move a stick towards it, it can sense that it wasn't all created. The impact it felt wasn't just the impact that it created on the stick,
right,
but it somehow senses that there was a reverse impact upon it.
Right.
And even though it was moving, it can sense that it's not just that I'm moving, so everything's okay. But this is something beyond the nature of what I would normally encounter if nothing else was moving.
So, starting from that premise that entities that interact with their environment, specifically entities that move and modify their environment, need to have some mechanism for distinguishing the results of their action from the results of the environment acting upon them, that leads to the necessity. You cannot avoid having a necessary component of feedback inside the organism. Could be as simple as a chemical signal, right? I mean, if you want to take a simplistic sort of computer-centric view of it, if I cause a motion, I'm going to suppress the sensor that says that I'm coming into contact with something. Very simple to do, and even in a computer code. If my programming led to this motion, then I'm going to send a different signal at the same time that suppresses that feedback.
An if-then kind of thing.
Right. Mm-hmm. Well, extrapolating from this, and I don't want to take up too much time, but extrapolating from this, one of the distinguishing characteristics that many scientists believe separate cognition of that form from consciousness is entailed in, believe it or not, language. So the idea that of many cognitive scientists and people like Steven Pinker and Daniel Dennett and some of the other philosophers and scientists who thought about this is that we can impose a narrative on this, what must be a much more complicated feedback loop for an organism with a much more complicated nervous system. And by imposing tags on different sensory, inhibitory, volitional, and response signals that bombard us, by putting verbal semantic tags on those, we are able to construct a reality that propagates through time. We can think about what happened previously, we can think about what happens tomorrow in a non-trivial way.
But you're saying slugs can do that as well?
No, slugs can't.
Yeah, okay.
Right?
Okay.
Slugs don't have that ability to think about yesterday or tomorrow. Now, there may be some kind of chemical reinforcement that happens so that habituation, like Pavlov and his dogs and whatnot, although a dog is much more complex than a slug, neurologically speaking. But that habituation process could take a purely chemical, relatively straightforward format in a simple animal like a goldfish or a slug or an earthworm. But the opportunities for imbuing complexity into that feedback loop become manifestly, phenomenally greater once you can develop a mental vocabulary, the ability to process things as signals and symbols, and then you can begin. Consciousness entails manipulating those signals, those symbols, volitionally, without necessarily having to relate them to some kind of sensory input. So evolution is this ladder that climbs up layers of complexity. So the simplest layers, like a garden slug, evolved for survival, pure survival mechanism to enable a slug to move without reacting in fright, as it were. That same mechanism was the first step, the first rung on a ladder that led to greater and greater levels of abstraction in neural processes that eventually led to considering the effects of one's actions or predicting the effects of one's actions. And some evidence for this comes from people who've had damage to their brain in verbal areas. They are unable to make plans about things because an integral part of that kind of planning is verbalization. So there's a whole separate topic that we can talk about, the importance of language. But I wanted to share this idea that even elementary cognition, the idea of stimulus and response, things that happen to an entity of its own volition versus environmental stimuli, a need to differentiate those things, the very basis of information processing, must have arisen early in the evolution of any animal, even a simple one.
And that leads towards some of the concepts I wanted to talk about with cognition and consciousness, and kind of looking at it as an end result, which I think you were getting to there. Some aspects, what really set our species, humans, off on our special path was probably not intelligence, some people feel like. It's not that we have this greater intelligence than others. It was often thought of as the possibility of communication, this social skill. Consciousness allowed for communication. If we're conscious, we're looking at the world, we're seeing how we react to it, and we're aware of what's happening out there in the world. And so then we can use that consciousness to communicate. Animals maybe develop the ability to infer what the thoughts and mental states of others were, maybe by observing gestures initially.
Especially social animals.
Right.
Yeah.
And consciously developing an understanding of the other's state of mind. It's critical to be able to be aware of you as an entity and your fellows as an entity too, to be able to just develop the capacity to communicate. If you don't comprehend any of that, that there's others out there with their own drives and feelings and thoughts and so on, then you can't really communicate with them because you have no concept that what you are saying is something that they don't know. There's no aspect for learning or teaching or so on. But that's a pretty interesting part. That's somewhat then, maybe is what you're saying, is that there's an evolutionary case for consciousness.
Absolutely.
The consciousness that develops as things have evolved over time makes this conscious thought have a capacity for advancing that species.
Right. One of the other things that I've learned in my research is, not my original research, my reading of experts, is that the fact that we are a social species may be inseparable from the fact that we evolved language and consciousness, and the need to gauge the actions and reactions of others, to predict their actions and reactions. If we were a solitary species, it's plausible that some of those neural mechanisms that enable that would not have arisen.
Right, right. Evolutionarily, information, there's two ways of passing information on. One is the evolutionary path with DNA and the transfer of genes and chromosomes and things we've talked about many times in Science Sunday. So just as DNA in our genome passes on information to further our evolutionary development, consciousness allows us to pass on information to each other. Just as Science Sunday, we pass on information that people have passed on to us. Mm-hmm. So this consciousness, this capacity to be aware that this is something that I know or I've been learning, and other people may be interested in it as well. This all allows, in this social structure you're talking about, to pass on information. Without consciousness, without this awareness of who we are and who others are and how we fit into the world,
you can teach people the difference between poison ivy and corn, right? Even though that may not be an instinctual thing that we recognize.
Right, right. There's even questions that social scientists have asked as they've gotten into the story of the mind and the brain. Would you even have consciousness without culture? How does culture play a role in all this, and how do we fit in, and how do we be conscious and aware? If you can't comprehend the fact that you are different than someone else, if you aren't aware, this quality or state of being aware, especially of something within oneself, if you don't have that consciousness, you can't communicate, you can't form a culture, you can't pass on knowledge. All this is some inherent capability that evolved over eons, that took the things from the aspect of a garden slug or a forest slug before there were gardens, and had that capacity to react to the world, and then evolve onto a creature like us, or dolphins, or different creatures that have some level of culture and social structure.
Termites and bees, right? They have very simple nervous systems, but the social requirement of effective communication is still relevant to things like ants and bees and simple organisms, and they develop their own, what we might call language.
And that almost, the culture provides the brain more than the animal itself.
Right.
When you talk about ants, the capacity of things that they can do. When you take one ant by itself, it's a very stupid being. It has no concept of how to live and take care of itself on its own, but it develops this culture which animals, different ants that have exactly the same structure to them, even the same DNA, somehow delineate their work, and some become workers, and some become nurses, and some have different aspects, soldiers and different things like that. And they can do things like building bridges across a river or across a chasm that individually they had no capacity and no concept of how to do. And so that's an interesting topic of the brain almost seems to be in this superorganism of the culture of the group of ants or bees that are together that individually none of them have.
Yeah, but it's the same, if you look at it from 10,000 feet, it's some of the same driving factors that are relevant to individual complicated beings. You know,
Right.
the survival of the colony becomes paramount versus the survival of the individual.
Yeah.
And so intra-colony mechanisms for communication become necessary.
I guess maybe to finish that off and move along, we can respond to things beyond the here and now. Most animals only reside in the here and now. But consciousness is crucial for the capacity to live in beyond the here and now, to put things towards the future, to see the future and the past and reflect on those things and have that have an aspect in our decision making.
Right.
Okay. Interesting topic that could go on quite a bit.
Oh, goody, this one's juicy.
Free will, another blunt segue here. Conscious thought versus unconscious thought. What makes a thought conscious? Are all thoughts conscious? What is it? Is there unconscious thought? All these different things go along. And so we started looking at some of these things. What makes a thought conscious? And actually, there's a lot of interesting experiments that have gone on, again, with putting EEGs and different kinds of sensing devices on people and seeing what goes on from there. Can we make conscious decisions, or are all decisions actually arrived at before we consciously understand and appreciate it? And that opens up a whole can of slugs or worms or bees or whatever. So I wanted to talk about Benjamin Libet. In the 1980s, he had an interesting discussion. He had an interesting theory. He was testing how thoughts arose. And so he set up an experiment, and he wanted people to decide when to put up their finger, to raise a finger and put it down. And he wanted to see, is that something that you consciously decide to do, or what is the process, the thought process that goes behind it? Very difficult to have people say, well, now, because this is another conscious decision to say something as well, too. So he didn't want to have that noise, that problem of people deciding to say now and when their finger went up, and that wasn't an accurate measure enough for him to decide. So he put up a rotating clock, a fast, quickly moving, rotating clock, and he asked people to, when they decided to put up their finger, to see what numeral the point of the clock was looking at. And he actually found out that people would then respond later. They'd say it was at 6 or 3 or whatever number it was at. And he was able to determine that was about a third of a second prior to people putting up their finger that they had decided to put up their finger. So he was saying that then thought is not conscious. The original thought was an unconscious thought that then you acted on at a point. Okay? So the finger was going up later than the time then people decided that they were going to put their finger up, and which he then started to feel like was a display of unconscious activity. Your unconscious mind makes decisions, and that opens up a whole issue of is there free will? Is there the capacity to do things? And how does that work? That everything is an unconscious decision? Why do we worry about deciding about things? We just are forced to do things by our unconscious anyways.
So Sam Harris wrote a book of the same name, Free Will, talking about these kinds of results. I have very mixed regard for Sam Harris and some of his intellectual output, but I think this is one of the more interesting and thought-provoking pieces of work he's done.
He always speaks so highly of you.
Yes.
So people started looking for answers for that, and one was Daniel Dennett talking about maybe when you're doing this, you're measuring too accurately. You're measuring things and you're coming up with numbers that are beyond the capacity of the numbers to really describe what's going on. He considered that that might be done in this experiment. Another person looking at it, so we'll keep fleshing that out as we go on. As we put on with unconscious thought then, if we're talking about unconscious thought driving everything, what is really unconscious thought? You know, it can be neural firing. When you, when your neurons fire at a point, it can fire without you thinking about it. There's some level of unconscious thought that regulates your breathing and your heart rate and different things like that. You know, and is that really thought or what's going on? How do you define what a thought is? Descartes would have never conceived of the capacity for there to be unconscious thought. So we're way beyond Descartes' views of the mind-body dualism and so on when we get to this point. Unconscious thought can sound almost like an oxymoron, because a thought implies in many ways, or has for centuries, the fact that it has to be conscious. If you can somehow then, after there's a neural event, maybe you recognize it. Maybe that recognition of it is a conscious thought finally. So these firings occur that you may or may not be conscious of. You're not saying there's a neuron firing in section 3AB17 or something like that in your brain, but you recognize the fact that there's a result at the end of it. And that comes to be a little bit more of what Daniel Dennett seems to be talking about. Stanislav Nikolov came up with some thoughts about this too. And he did some tests, or had some thoughts about that as well, and I thought it would be good to talk about a little bit of what he said on here. So Dennett was arguing that the Libet experiment really showed was that consciousness maybe was smeared across time, right? When he thought that if you're trying to measure too close, there's some level of consciousness that can't be predicted down to these nanoseconds of time, and consciousness is smeared over time, and that then it's a little bit of an oddity to try to measure it that accurately. It's almost as if you're saying, I want you to picture the DuPage Unitarian Universalist Church, and somebody says, well, it's obviously the sign that's the picture of the chalice that's on the outside of the building. To me, that's the Unitarian Church in DuPage. And other people say, well, no, it's not obviously that. It's the garden outside that Pat Clancy works on so hard, and the things that are out there, you know. And if you try to measure it so accurately, and each thing is an aspect of it, but Daniel Dennett is saying that each is only an aspect of it, and you can't just talk about when you recognize a second in time when you know you're going to put your finger up as that conscious part of it, just like we can't talk about any certain part of this, you know. Reverend Mike might say, well, it's obviously my office because that's where all my thinking comes in and my books are and all that. That's the DUUC part that matters to me. Or we might say this altar or this community. We're finding out that this community doesn't have to be here to still be a community, right? The DUUC church is meeting in the ether, let's say, for right now.
Our spirits.
Our spirits are meeting. Yes. So a model by Stanislav Nikolov talked about how the brain recognizes its own important neural events over and above the mere random chatter of neurons. So your mind, just as a function of being alive, there's this random neural chatter going on in your brain the whole time that you're around. And some of it is the perceptions that you see, the things that you bring into your body and you adjust to and work with. And others are many other things. But it provides a detailed justification maybe for Dennett's position. Nikolov's model showed that it was actually counterproductive to detect the decision when brain activity for the decision was just on the cusp of rising above the usual random baseline hum. Neural activity is always rising and falling, because the brain is a noisy, semi-chaotic place. What the brain needs to do is to carry out some solid, cautious statistical tests on its own activity and only trust that a decision has been made when collective activity gets up past some threshold. And it's quite high, clearly above chance, and this point is reached considerably later than the point at which this quiet ramping up process begins. So your mind is going through chaotic, just little humdrums of activity and behavior, and you start thinking you're tasked with putting your finger up at a certain time, and things start occurring then, and there's this thing going on, and you decide, yes, but your brain only recognizes that it got past this threshold level after things have already started on this point. Otherwise, the brain would constantly be misinterpreting chaotic noise as something significant and meaningful, and you would be flooded with all these different activities. You can almost think of it, let's say that you were on a military vessel 150 years ago out in the middle of the ocean, and you're tasked with being up there in the crow's nest and looking for activity on the horizon, right? And what you're supposed to find out is when this frigate of the enemy ship is going to come and engage you in battle. And so you're pretty excited. You're up there and you're looking for it. You might have a strategy that you could decide that I need to warn people so that we can get ready, and any activity you see something and you decide to react to it. And you call below battle stations and everybody hurries and gets ready. And then they start for 5 minutes getting to their battle stations, pulling out the cannons, loading the cannons and getting everything ready. And then you realize that it was maybe a gull flying low on the horizon.
It was a frigate bird.
Right. I hate those frigate birds.
Yeah.
And it was a dolphin breaking the water, or it was an especially large wave or something. And you feel like after you realize that after you've called down 50 times in your 4-hour shift up in the crow's nest, that everyone is getting pretty fed up with the fact that anytime there's some slight little rise of perturbance of activity on the horizon, you're actually going out there and calling for battle stations. Then you decide, your next shift, that didn't make you very happy with your messmates down when you finally got downstairs. So you go up and you realize that this has exhausted them. They've put out all their activity to get to battle stations 50 times in a 4-hour time that you had up there. You realize that you're going to back off a little bit, and there may be something on the horizon, but you wait until you have very good knowledge that it's an actual enemy boat, ship in your sight before you call down to battle stations. People are much more rested, they're ready to go to battle, they still have time to get ready and do these things, and it's not of a significant nature that you waited another 15 seconds, let's say, or in brain time, 1.5 milliseconds or something like that to verify that this was actually what you thought it might possibly be. So you're going to only alert the captain when you're reasonably sure that an enemy ship is detected. Then it went further from that, and we'll probably have to stop at this point. There's more to talk about, so we may be needing to make a conscious decision or an unconscious decision to have a further Science Sunday about this. But a further experiment was done, and this time it was with either right finger or left finger. And people were going to decide they were going to put up their right finger or their left finger, okay? So there was similar types of things. Again, it waited until enough neural activity is present to confirm that a decision was going to be made. but with choosing a right or left finger movement, and then they timed it and saw how long it took before they could see that that a decision had somewhat apparently unconsciously been made, and they could see there was a different area of the brain being activated for right or left finger, and they could see the activity of the brain, timing of which finger was going up. If you'd come up with an amount of time that you'd think it took before people actually put, from the time it could be determined to the time that the finger went up, right or left finger, would you have a guess as to what that is?
I don't. I mean, earlier you said a third of a second, so.
Yeah. Well, that was just to determine that a third of a second from the time that a person decided to put up a finger, or the time they saw activity doing it, to the time that finger went up. This is a little bit different, more complex, but it was up to 10 seconds before the conscious decision of raising the finger actually happened. Not always 10 seconds, but it was, sometimes it was 10 seconds and people were still not, they didn't realize it, but finally they put up that finger, okay?
That reminds me of piano players and touch typists that can create notes on an instrument. It's not just pianos, saxophones, anything. Can create notes on an instrument or write words on a typewriter faster than any signal could have traveled from their brains to their fingers. And so the your neural paraphernalia can engage in actions outside of your conscious thought and outside of the direct control of your brain. Even.
Right, right. And they tend to call that muscle memory, that things are passing back and forth, and it has to do with practice, and it has to do, they don't generally get to that point unless they're a very talented, let's say, violin player or whatever. And also, if they've practiced that piece, they aren't even thinking. They can play the whole piece and actually end up at the end of it not remembering any decision they made, any thought that you put the finger here and you go, you do a...
Or you did the expression, the expressive timbre and whatnot.
Yeah, the aspects of that all have become the fact that conscious activity, once it's done long enough and often enough, often becomes unconscious. How many people have gotten to work, driven your car to work, and you realize you don't remember that you passed through that stoplight where the grocery store is and the gas station and everything. You don't remember whether you stopped there or not. That's not to say you're a terrible driver. It's to say that you're unconsciously handling those tasks. And then, if anything intrudes that's any way out of the ordinary, you're back in.
Somebody touches you with a stick.
Yes, you completely repel and go back in your shell. So the capacity of us as humans to take activities that are conscious and perfect them to the level that you can't even recall that you did them. So many activities during the day. Making dinner sometimes, that can be done to that level that it's completely, you get into washing dishes and you're actually thinking about so many other things. That comes into some really interesting topics. What is the capacity of the brain to remember, and what can it keep conscious in all its aspects? And that was coming up, but I think we'll have to save that for next time. Fascinating stuff. Really engaging to talk about. Hard to limit the topic in this thing at all. I don't know. Are there any questions or thoughts that came up, Scott? That
I just see a bunch of dazed faces. No, I don't. I don't actually see anybody. But we got one comment. Somebody says, "A great topic. Keep it going." So that was from Randy.
Okay, nice. Well, yeah. There's a lot of things. How do you get into these states? Randy is pretty interested, I know, in meditation and so on. And what is meditation, and what kind of state are you in there? Is this, you're so conscious of certain things that other things get put outside of your mind? A lot of what I want to talk about next is some level of consciousness and attention. Things become important.
I have some ideas about free will, too.
Because you tend to, okay.
Yeah.
All right, good. Well, do you have something you want to close with, or do you want to hold it for next time?
Yeah, it's pretty brief. So
okay.
regarding free will, one of the examples I've used in the past when talking to people about this topic is there's a plate of cookies in front of you. There are raisin oatmeal cookies and chocolate chip cookies. And you have a preference. I don't know what your preference is, but you have a preference. Now, you may override that preference. You may deliberately say, well, raisin oatmeal cookies are a little healthier for me, so I'm going to take that. But if you have really integrated that viewpoint into your worldview, then you will consistently take raisin oatmeal cookies. Or maybe you just prefer them. Whereas other people may prefer chocolate chip cookies. That's one example of how you have perfect latitude of action to choose either cookie. But you will consistently choose a cookie that you prefer, either for rational reasons or just because of some emotional preference. Your whole life is a series of expressions of these kinds of preferences. The brain, one of the things that Steven Pinker has said is that the brain is a series of almost discrete organelles, like a cell has organelles within it, or your body has organs within it. And there's this constant dialogue and war between different parts of your brain to try and motivate a particular action. That's why people can say things like, well, I'm of two minds, or I go against my better judgment, right? Or I'm doing the short-term gratification over long-term gains. Every time you do that, every time you make a decision about any preference or any behavior, you have a great deal of latitude, and that in no way impinges upon your free will. And yet, you are a consistent being. You are the sum total of all the experiences, preferences, desires, plans, and stimuli that are personal to you. So whenever you react to one of those stimuli or preferences, you're exhibiting what we call, prosaically, free will. But if I know you well enough and I've seen you at enough parties, I can predict with damn near 100% certainty which cookie you will choose. And there are many other things that we do to build models of other people in our minds, and that in no way robs anybody else of their free will. So it's a bit of a misnomer. It's a bit of a misapplied term. And people confuse it with randomness, for example. And nobody wants to behave or does behave randomly. And if they do, we consider them to have a mental disorder. So free will is a dangerously evocative topic that incites a lot of passionate debate and feelings of affront among people. But I think that it's a loaded term that is not generally applicable to the kinds of processing we do as consistent, deliberative beings.
Okay. Well, yeah, it seems like when you define this aspect by free will, it almost salts the mind a little bit. It makes it hard to discuss this in a way because people have their aspects of how they want to admit that free will is there or is not there, and causes challenges that maybe you could have agreement on in aspects of this, right? And calling it free will tends to make some hardened hearts, I'd say, or draw some hard lines.
Free will, freedom of action provides a large latitude of possible outcomes and behaviors on your part. Do you have those large latitudes? Well, if you're not imprisoned or enchained or in other ways constrained by law or external forces, then you have a great deal of latitude. And your ability to execute that is a manifestation of what we might conveniently call free will. But the fact that you exhibit the same kinds of tendencies again and again goes into defining the constancy, the predictability, the certainty of your individual personhood that other people and yourself can recognize and pick out of a crowd.
Great. All right, well, I think we'll pretty much end it there. My book that I used quite a bit of thought from was The Ravenous Brain by Daniel Bohr. Lives in England and is a brain researcher in England. I also want to thank Ann Ariano for giving me I took the free will and I decided to dress up a little bit more than usual.
Yeah.
So
nice.
I have my Einstein tie here that Ann Ariano and her son passed on to me. and I appreciate it very much.
Yeah.
Haven't worn it before today. I think I showed it at another Science Sunday, but that was my free will choice today.
Yeah, well, I predicted that you would do that. No, I didn't. All right, so one of my primary
Did you
books...
predict I'd eat it?
Yeah, oh no, I had no idea. One of my other books, I read several, but one of them that I really recommend to all of you is Other Minds, The Octopus and the Sea and the Deep Origins of Consciousness. My example about the slug in the book, it's actually an earthworm, comes from that, and there's some really nice stuff about cephalopods and primitive consciousness versus complex. Anyway, great book also.
I think I mentioned it earlier, but there is a very interesting movie out. I think it's available on Netflix called My Teacher, the Octopus, and it talks about a man who changed his life by meeting and interacting with an octopus over the course of a year down in South Africa in the ocean. So very interesting topics. Thanks a lot for coming here on Science Sunday. Thank you very much to the AV team. You guys, Chris, you're awesome up there. Appreciate it very much. And again, thanks to the church for providing us this forum. So have a great day. Get out there and vote.
Next time I'm going to talk about the science of cooking. We're going to be close to
Yeah.
Thanksgiving, so a little change of pace.
Sounds good.
All right.
All right. Thanks much.